GLM 5.2. This is the model everybody's talking about. Now, it's not only about its impressive scores on benchmarks, it has a long context window of 1 million token, which is 5 times bigger than the previous generation. But in this video, I really want to focus on the architectural details, which makes it one of the most impressive open model releases so far. It seems like this is the first open weight model that is actually close to the frontier. Okay, if you have been looking at Chinese labs, you are going to actually see some interesting patterns. And this is constant across DeepSeek, Minimax, and now Z.ai as well. They're not winning by throwing more compute at the wall, they are winning on efficiency. GLM 5.2 is an open weight model under MIT license, which means you can just download it and run it yourself. But even if you're using it through their API, it's pretty cheap. And the interesting question is how this model, which is so big, stays so cheap. So let's start with how it is actually built. Now, this is a mixture of expert of 744 billion parameters. It's definitely much smaller compared to some of the other frontier models, but in terms of performance, people are actually reporting some really incredible results. Now, since it's an MoE, these parameters are split into 384 separate experts. And the beauty of this is that for any given token, a little router picks only a handful of those experts to actually do the work. So even though the model holds 744 billion parameters, only about 40 billions of them fire for each token. Now, this is a trend that we are seeing across the industry. We're seeing more and more MoEs because they are a lot more efficient and you need a lot less compute in order to run them. And this is kind of the trick that everybody's trying to adopt these days. Now, as I said, this context window is about 5 times larger than the previous generation, which also makes it harder to run. In classic attention, every token has to look at every other token to decide what matters. When the context is small, that's no problem at all. But the number of these connections grows with the square of the context. So it really explodes. At a million token, that will be a wall of connection exactly where the cost blows up. So the whole game becomes on figuring out which connection you can safely skip. So this is where the concept of sparse attention comes in, and GLM 5.2 built on DeepSeek's version of it. Now here the idea is to add a small cheap component called indexer. Before doing the expensive attention, the indexer scans the context and picks out just a handful of tokens that actually matters. Then the real attention only runs on those. So most of the expensive connection just disappear. It's kind of like a librarian who, instead of making you read the whole library, hands you the 3 pages you actually need. Now, the catch is that the model has many layers. And naively, you would run that indexer all over again in every single one. And that's exactly the problem index share solves. So instead of computing a fresh indexer in every layer, GLM 5.2 compute it once and reuses it across 4 layers in a row. So 3/4 of that indexing work is actually just vanishing. The result is that it's a 2.9 times fewer compute operation per token at the full million context window. And it's the same librarian now serving you 4 floors of the building instead of hiring a new for each one floor, if we want to go back to that example. And this single trick here actually makes it possible to serve these models at 1 million context window. Okay, so that was the cost of reading a long context, but what about the cost of, or the speed of writing the answer? So GLM 5.2 uses multi-token prediction, which is kind of becoming a standard, where it guesses several tokens ahead and then verifies all of them in a single pass. When those guesses are good, it keeps them, so it gets multiple tokens for the price of one step. They improved this enough to raise the acceptance rate by about 20%, which directly shows up in the speed up of the inference. So between indexer and this, both reading and writing at the long context gets a lot cheaper at the same time. Now, one more practical touch here. GLM 5.2 gives you 2 thinking effort levels. So there is a high mode which balances performance against how many tokens it burns thinking. And there is a max mode which basically opens it all the way up for the hardest problem. So you get to pick the cost versus capability trade-off that task. So you get to pick the cost versus capability trade-off per task instead of being stuck with one. And we are seeing this pattern that when it comes to reasoning models providers are enabling multiple different reasoning budgets or thinking tokens. So you want to tweak these thinking efforts based on the complexity of the task. Now, the way they launched this was very interesting. Initially, there were no benchmarks at the launch, but later on with the open weight release, they actually also provided the benchmarks. And you probably have seen them by now, right? So it's really impressive on agentic coding. On Frontier SWE, the long horizon test, it's delivered 74.4%, which beats GPT 5.5 and basically is tying up with Opus 4.6. Kind of incredible. Now, the main story is not the benchmarks. I think there has been a lot of conversation regarding benchmarking, but the main thing is that when it comes to actual coding tasks, especially from front-end UI designs, it's a beast. It's really close to Opus 4.8. And if you haven't tried it, I'll highly recommend to test it out. Now, let's talk about pricing, because I think this is where the Chinese labs are actually winning. Although they're supposed to be compute constrained, but the pricing they offer compared to some of the US counterparts, it's simply incredible. For example, this is almost 10 times cheaper than Cloud Max for a similar amount of tokens. But even if you're not using the GLM coding plans, you have quite a few options when it comes to this model, because there are US-based hosting solutions who are providing Inference. Or if you have enough compute, you can simply host this model yourself, but you will need a few H100s for that. So being open weight, this gives you a lot more flexibility and you are not tied up to a single provider. Okay, a couple of things before we wrap this up, right? So the first thing is that if you're using their hosted API, you need to think about how comfortable you are in terms of sharing your data. There's a lot of concern about it, but as I said, there are options available because the open weights are basically the escape hatch here, since you can run it on your own hardware. Now, it's a beast when it comes to agentic coding, but there are a few other things to consider. First, it's text only, so it doesn't have vision capabilities. Second, you actually want to look for a harness that is well tuned to this specific model, rather than using it in something like Cloud Code, which is not probably specialized for GLM 5.2. So you want to experiment with quite a few different harnesses if you want to try this model out. But in general, we are actually seeing a very interesting pattern that I kind of alluded to in the beginning of the video. The Chinese open-weight labs keep winning on efficiency, and the index share is exactly that kind of unglamorous trick that quietly moves the cost needle. So I won't pay much attention to the benchmarks, but the main thing is these labs are actually competing with frontier labs now at a much reduced cost, and being open weight, that gives them a lot more flexibility. So what do you think? Is efficiency the real frontier now, or does raw scale still win in the end? Let me know. I hope you found this video useful. Thanks for watching, and as always, see you in the next one.